Mockles, and you're listening to Looking Up with Don. This is the Looking Up with Don podcast, episode 12 for the week of March 25th, 2020. This podcast is virus-free. The related website for the podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, March 25th, the moon is a day past its new phase and is now entering our evening sky as a slim crescent. Over the next week, it will grow in brightness each night, move eastward about 12 degrees a day, set an hour later each night, and on April 1st, the moon will be in its first quarter phase. So the moon will be in our evening sky and not terribly bright. Just because you might presently be self-isolated, quarantined, restricted, sheltered in place, social distanced, locked out, locked in, scattered, shattered, or tattered, doesn't mean you can't enjoy the night sky. The sky doesn't have any viruses, and the heavens will do what they want despite the problems down here. Look forward to the day, and it will come when this will be over, and life will get more or less back to normal. There are good days ahead. We already have good nights. In fact, if you want something to look forward to, we may have a bright comet in our evening sky in mid-May. More about that later. Venus is high in our western sky. Watch Venus each night for the next 10 nights, weather permitting. The moon passes just south of the planet Venus on March 27th and 28th. That's a good photo opportunity. But that is not the most exciting thing to watch for. Venus moves a degree a day eastward and is approaching the open star cluster known as the Pleiades, also known as the Seven Sisters. Venus will pass through the southern part of that cluster on April 3rd. This is a must-see event. So for the next 10 nights, watch as Venus makes its way across the sky toward the Pleiades. The morning sky still has the traffic jam of the planets Mars, Jupiter, and Saturn, all grouped in the southeast. Actually, the former planet Pluto is in the mix too, but it's too faint to see without a large telescope. Mars passes south of the planet Saturn on March 31st. The International Space Station is visible this week depending upon your location. North of about 40 degrees north latitude, England, Canada, Russia, northern U.S., places in which you get snow, you'll get 1 and perhaps 2 International Space Station passes each evening. As you move south of that latitude, at 35 degrees north, the space station will not be visible all week. At latitude 35 degrees, it's not visible until March 30th, and then it will be in the evening sky each night. As you move further south, it will not be visible until the first week of April. Between about 20 degrees north and 30 degrees south, it will not be visible at all next week. South of there, it will be visible in the morning. To determine where it will be in your sky, you can go to the website Heavens-Above and enter your location, then click on International Space Station. Public star parties. Last week I discussed public star parties, what they are, and so on. This week I'll discuss how to organize one, or at least how I organized star parties for the 25 years in which I did them. At this time, it might even be illegal to hold a public star party. But it will not always be this way, and hopefully a month or two, it's hoped that in many areas, the coronavirus will have peaked and people will be less restricted to travel and meet. This summer would be a great time to get out and show people what's up in the sky. By early July, both Jupiter and Saturn will be in our evening sky, and they will both remain easily visible until late December, when we will have an amazing view of both Jupiter and Saturn in the same telescopic field of view. If you're thinking of holding a public star party to show these two major planets to your neighborhood, remember they are in the southern sky, so make sure your southern horizon is not obscured by trees or mountains. If you also want to show the moon, then the last weeks of July, August, September, and October will also have the moon up, but it will also be in the southern sky. There's many items to consider when organizing a public star party. Where will it be held? Who will bring the telescopes? What will we show? And when will it be held? I used to sit down at the beginning of the year and plan all the year's star parties. First, I looked at the astronomical calendar. Are there any lunar or solar eclipses, planetary conjunctions, Mercury transits, or bright comets expected? Those events usually earned a star party. What's Mars doing this year? When Mars is at opposition, which it is every 2.2 years, public interest was high and when we got good crowds. When will Mars, Jupiter, and Saturn be at opposition, as the viewing season for each of these planets begins shortly after their oppositions when they're in the evening sky. And then there's something called Astronomy Day, which is held worldwide each year. It's held in the spring on a Saturday, and that is a date that many astronomy clubs hold events for the public. They choose a date when the moon is in the evening sky. Next, I determine what type of star party it will be, dependent upon where it will be held. In a light-polluted area, I'll choose dates when the moon, near first quarter, is in the sky. The first quarter phase of the moon is about right, enough moon to show a good view of the moon, but not so bright that it washes everything else out. As for the day of the week, we have held public star parties on all days of the week, but have settled on Saturday nights unless there's a special astronomical event. Saturday nights give astronomers a time to arrive and set up. It gives time for the guests to arrive, and most people do not need to get up at 5 a.m. the next morning for work. Also, it's not a school night. At dark sky sites, the Sierras, we had a short season. From May, when the snow had melted, to mid-September, when it would start to get cold in the evenings. Also, with dark skies, we made sure the moon was not in the sky so that we could take advantage of the dark skies. As for the start time, I picked the nearest half hour to the evening twilight with a couple exceptions. In the midsummer, we began at 9 p.m. It was medium but not bright twilight, but before it got darker than what we would like. Starting later than 9 p.m. puts it too much at the end of the day when people are tired. Starting earlier puts us in a position where we would not be able to start showing things until the sky got dark. In the winter, we often did not start until 5:30 at the earliest, but typically 6 p.m. Our sessions lasted 90 minutes, unless a lunar eclipse or Mercury transit extended it. Now, 90 minutes was a good fit for us. We did not wear out the astronomers with longer sessions, and yet it allowed the guest plenty of time to get out and look through the telescopes. So where do we hold these star parties? Well, we often held ours in state, county, or city parks. And you need to seek permission first, since many parks want you gone an hour after sunset, which is about the time we begin. At Big Bend, California, we held them in the parking lot for a popular trailhead there. The ranger with the U.S. Forest Service helped to host them. He publicized them during the weeks beforehand, and he was with us during the star parties. You do have to scout out the location beforehand, both preferably in the daytime and at night. You want to see if there's neighbors around, and where your guests can park while you're there in the daylight, and the heights of the local horizons and where the light pollution sources are at night. We almost always had a restroom nearby, as most parks do have a public restroom. In any event, get permission. You don't want the police showing up to ask you to leave. We seldom held a public star party on private property, but don't overlook that option. As for liability, like if someone gets hurt or something, we never carried insurance and we never had a problem. I don't know if that's a good idea. We were not an official astronomy club. It was just a group of 4 or 5 individuals setting up our telescopes and showing people stuff. An astronomy club might consider insurance for events like this. Who's going to handle the telescopes? You can do a public star party all by yourself, but if you get a lot of guests, you'll be swamped and the guests will have less time to look through the telescopes and you'll have long lines. So get some more astronomers involved and committed in doing this with you. Get dependable people, not ones who will cancel the last minute. They don't need to be well-versed on everything astronomical, but they do need to know how to operate their telescopes and a little bit about the objects they will be showing. We have had talkers, that is, those who want to explain everything to everyone, and those who are more reserved. The star parties are not about us. We're not there to try to show people how much we know. The guests are there to see the sky and get a better understanding of astronomy. Make sure that the telescope operators, who we refer to as the host, are there and set up with the finder scope aligned and perhaps their go-to telescope aligned prior to the start of the star party, and always start on time. Not all of your hosts even need to have telescopes. You might have someone there to point out the constellations or help someone else to operate a telescope. You may have a spare telescope there that they can operate, or you might have someone there just simply to direct traffic and hand out printed materials. At our public star parties, we handed out a star map for the night. We handed out our star party schedule for the year, usually a list of websites, and sometimes a list of the objects that we planned to show with a one-line explanation of what each object was. Now, your host, that is the astronomers, have 2 jobs. First, to point the telescope at an object and keep it in the field of view, which is not easy since people inadvertently will move the telescope without even knowing it. Second, to explain what it is the person is seeing through the telescope. To say this is the Andromeda Galaxy is not enough. Explain how big it is, how far away it is. 2 or 3 sentences is usually enough. You will be repeating it several times as guests walk up to your telescope. What is it you're going to show at your star party? I've discovered that the 3 most popular objects are Saturn, the Moon, and Jupiter, in that order. Show stuff that people will see. A quasar might be interesting, but your guests are unlikely to be able to see it. But having said that, on a couple occasions, we did show Pluto from a dark sky site in our largest telescope, and most people said that they could see it. But stick with the stuff they are likely to see. Nothing is more discouraging than saying something is in the eyepiece and your guests can't see it. And sometimes people will say they saw it even when they did not. At Big Bend, where I would give a 5-minute introductory talk, I would tell them that if they did not see the object, then say so. It might not be in a field of view, or perhaps they do not know what they're looking for. I'd say, hey, you didn't come up here to pretend to see stuff, so tell us and we will work with you until you see it. You might also want to check the satellite schedule for passages of the International Space Station or even the Hubble Space Telescope. These are satellites that the public is well aware of, and they would usually be interested in watching them going across the sky. Then, a couple minutes before they appear, we take a pause and direct the guest to search the area from where it will appear. That can be one of the more exciting times of the star party, as usually everybody's quiet and they're scanning the sky looking for the satellite. Some people want to be the first to see it, but once most people begin to see it, also use your laser pointer to point it out so that everybody's on board as knowing exactly what it is you're looking at. And yes, in fact, that is a satellite we were expecting. At the dark sky sites, we also take about 5 minutes in the middle of the star party to pause while one of us pointed out the brighter stars, maybe 3 to 5 constellations, the planets in the sky, using a laser pointer. The most valuable space at the star party is the ground in front of the eyepiece. I have always tried to be efficient, letting no starlight go to waste. Besides, people are there to see the stars, not sit and chat, or wait for the astronomer to locate the object. They do not want to stand in line for long periods of time. This is not Disneyland. We can do better than that, and we give the guest a good show. Occasionally, someone will look at something through the telescope, then stand there and want to know where it is in the sky, or look up from the eyepiece and ask a few questions about the object. I'll say, sure, let me point it out, or I'll answer your question the best I can. Let's let the next person look through the telescope while I do this. Have them step aside so the next person can view. We have digressed. Let's get back to what we will show. For the light-polluted star parties near town, where the guests often come for only perhaps a half hour, we always have a telescope on the moon and maybe 2 telescopes at different magnifications. Everybody wants to see a low-power view of the moon where the moon fits inside the field of view. And then you have a second telescope with a high magnification view of the moon where they can actually see the craters and some of the other features on the moon up close. People, when they see the moon, one of the first things a lot of them say is, wow, it has craters. At those star parties, we usually have a telescope on each of the bright planets, with our best telescope on Saturn, cranking up the magnification so that the rings can be easily seen. People are impressed by the rings of Saturn. The planet Mars is almost always a disappointment through the telescope because the guests have an expectation of Mars should look like through a telescope. Mars is small, not much contrast, no moons, and often it's not even red. But if it is up, we will often show it. In the light-polluted areas, we may also show a bright star or 2, a couple double stars, an open cluster, a globular cluster, and a bright galaxy. We don't leave this to chance. As the coordinator of the star party, it's your job to ask each host to show a particular object. So I would walk through the telescope field, ask Larry, for instance, can you please pick up the double cluster because it looks good in his telescope? Ask Dave if he could move over to this object or that object, and have them show those objects for a while. Since we do not have a telescope for each object, our remaining telescopes, those that are not on the moon or planets, would each show a few of the lesser objects. Our dark sky star parties were run differently. We notice that when the guest must drive an hour or more, they often stay for much of the 90 minutes. So we gave them a sky tour, showing them 30 objects in 90 minutes. Beforehand, I'd make a list of 35 to 40 objects visible that night from brightest to faintest, generally with a one-line description for each so that the astronomer can use that to describe the object to the guest. The list starts with bright stars, Those are visible in twilight. Then as the sky darkens, we show double stars, star clusters, nebula, and galaxies. With the Milky Way up there, as it is during the summer, there's a lot of objects to choose from. Then, 10 minutes before we start the star party, us astronomers would gather with a list and pens to divvy up the objects. 30 objects, 6 telescopes, 5 objects per telescope. The astronomers got to choose which objects they were going to show. Each observer was to keep their object in the telescope for about 15 to 20 minutes. Ideally, the guest would start at any telescope, a few guests at each, and go from one telescope to the next, and when they moved to the next telescope, they'd be looking at a different object. In Forest Hill, we had a big parking lot and set up in a circle, so they just went from telescope to telescope. By the time they got back to their original telescope, a new object was waiting there for them. At Big Bend, due to the shape of the parking lot, we were set up in a line, and when our guests reached the last telescope, they walked back to the one at the other end of the line and started again. Now, in practice, this plan had its difficulties. Some astronomers spend a lot of time with their guests, holding them on with stories or whatever, while others would get the guests through the lines more quickly. Long lines there, short lines here, where ideally all the lines would be about the same length and move at the same speed. Secondly, sometimes the guests would camp out at one telescope and wait for that astronomer to find the next object without running through the line of telescopes to see other stuff. And again, they would therefore end up seeing only perhaps 5 objects. However, overall, it was a good plan and allowed the guests to see a wide variety of objects in a short time. It was like a universe sampler. To have 30 people see 30 objects in 90 minutes is amazing. That's 900 sightings, or 10 per minute. Ideally, a person would be seeing a new object every 3 minutes. This was a rich experience for our guest. At the official end of the star party, I would often announce that the star party is officially over, where and when the next one will be, and that some of the astronomers will be hanging out for a while longer, and the guests are welcome to stay and talk with the astronomers if they wish. So how do we tell the public about these star parties? I often use radio and the local newspapers, and in time the editors and radio personalities got to know me and would sometimes interview me about the events. I also developed an email list and sent out notices a week before the star party. In later years, I wanted to start a Facebook page or a Twitter account so that we could notify interested parties about the event and even let them know if it was being canceled due to weather at the last minute, but we never did that. I think it would have worked out well to have a Facebook page or Twitter account to tell people about the star parties. So there you have it. If you're so inclined to hold public star parties, that is how to get them started, or at least how I ran them. Your location and weather, support group of astronomers, local regulations, and your personality will dictate how you run them, but these are a few ideas. Let's spend a few minutes talking about comets, in particular Comet 2019 Y4 Atlas. It'll probably become known by a more proper name, Comet Atlas. Now, there's several comets called Atlas, but this is presently the brightest and most watched comet, Atlas. Everyone seems to be watching and imaging this comet, and it's become a major buzz feed. It was discovered by an automated sky survey in Hawaii on December 28, 2019. Atlas stands for Asteroid Terrestrial Impact Last Alert System. I first discussed this comet 2 weeks ago, and last week suggested you keep an eye on this one. We will all be watching this one carefully for the next 2 months. It might do some spectacular things. Every comet is different. That's a good thing to remember. And every comet is unpredictable as far as brightness and appearance. We do not know from one night to the next what a comet will do. They generally follow certain formula, but they have been known to outburst, fizzle, turn on, and shut down. For this Comet Atlas, same thing. We do not know the future. It will be getting close to the sun, 4 times closer than we are in late May of this year. We know its predicted position in the sky, where it will be each night. Now that's predictable. But the question is, will it perform or not? How much will it brighten up over the next 2 months? Comets that go close to the sun, as this one does, move rapidly through space as they approach the sun and as they recede from the sun. So brightness change can occur rapidly. However, this one so far seems to be quite exceptional. Beginning in mid-February, the comet has brightened significantly, and if it keeps up, this will be one of the brightest comets ever observed. But remember, comets are unpredictable. Remember Comet Kohoutek in 1974? It was expected to get very bright, and it did well, but not as well as predicted. We did not fully understand it at the time, but we do now. Comet Kohoutek was a new comet to the solar vicinity, and the rapid brightening, while it was still far off, was the more volatile materials burning off. As it continued in towards the sun, that rate of brightening did not persist. That rate of brightening, in fact, decreased. This Comet Atlas is different. Comet Atlas's orbit is similar to the Great Comet of 1844, and it is believed that they are related. Perhaps they broke off the same original comet, but they're not the same comet, as this one, Comet Atlas, has an orbital period of about 5,000 years. So this comet has been here before, so we're not being fooled by those abundant volatile gases being burned off early. They burned off eons ago. Presently, this comet is about magnitude 8 and visible in binoculars in a dark sky. It is expected to get brighter until late May. Right now, it's in the far northern sky, so the southern hemisphere will not see it until after it goes around the sun, and even then it will be difficult from the southern hemisphere, as it will be near the sun as seen from the earth. So this is mostly a northern hemisphere comet. Some are southern, some are northern. That's just the way it is. I encourage you to watch this comet as often as you can for the next 2 months. The path of Comet Atlas is plotted on podcast 12, map 2. Watch it develop. If it behaves normally, and that's a big if, then our best views would be between May 9th, when the moon gets out of our sky, and May 20th, when the comet will be too close to the horizon in evening twilight. During that time, the comet will be in your northwestern sky, so plan to observe it from a site with a low northwestern horizon. Over the next 10 days, as we near the end of May, the comet will be visible in the morning sky in the northeast. When it's closest to the sun, and that will be 11 degrees seen from the Earth, it will be a couple degrees from the Pleiades star cluster in strong twilight in the morning sky. But watch it leading up to that time as we go through April. Will it continue to brighten rapidly? Only time will tell. There is another comet in the sky that bears watching. It is Comet Pan-STARRS 2017 T2. Use podcast 12 map 3 to find this comet. It's magnitude 9, and it's not likely to brighten much. Our unaided eye challenge this week is to learn the constellation Gemini, the twins. This is a winter constellation in the northern hemisphere. It is labeled on podcast 12, star map 1. The constellation Gemini is in the shape of a rectangle with 2 bright stars, Castor and Pollux, at the northern end. The constellation is along the zodiac That is, the ecliptic passes through it, which means the sun, moon, and planets trek through this constellation from time to time. In fact, on March 31st, the moon enters the constellation Gemini. So get familiar with Gemini. Our binocular object this week is Comet Atlas. Use podcast 12, maps 1 and 2, to go out and find Comet Atlas. If you don't see it initially, keep trying day after day, week after week. As the comet brightens, it should become visible to you in your binoculars. Our telescopic object for this week, actually we have two. One is Comet Atlas, the other is Comet Pan-STARRS. You can find positions for the comet on podcast 12, maps 1, 2, and 3. Now for fun with the marathon. The Messier marathon, that has seen all 110 of the galaxies, clusters, and nebula, which Charles Messier placed in his catalog in one night, seems to be dropping by the wayside this week. Because of the coronavirus outbreak and orders by various government authorities restricting public events, astronomy clubs have been canceling their scheduled Messier Marathon star parties. The All-Arizona Messier Marathon that was scheduled for March 28th has been canceled. So if you had planned to go to the All-Arizona Messier Marathon, it will not be held this year. But don't let that stop you. Sure, it's fun to get together and marathon, but you can also do it by yourself. Most of my Messier marathons I have done by myself. On the night of March 15th, 16th this year, just a week or two ago, I did a Messier marathon from my home in Arizona. Now the moon was half full in the morning sky, or third quarter phase. Using my 6-inch reflector, I picked up 109 of the objects, missing only M30. The weather these last few days and the forecast for the next week shows mostly clouds and some rain, but if weather permits, I plan to get out and do more marathons using different instruments. You can download the Messier Marathon search sequence from my website. It's podcast 5 search sequence. And if you want some star maps for all of the Messier objects in search sequence order, you can download the maps from podcast 5 through 11. Or you can use your own maps or use your go-to telescope. You have been listening to Looking Up with Don, podcast episode number 12 for March 25th, 2020. Once again, the related website for this podcast, where you can get the free star maps, is donmachholz.com. That is spelled DonMachholz.com. There's 2 H's. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We'll discuss what's going on in the sky, Comet Atlas. I'll share an ambitious event we held nearly 20 years ago that we named 7 Nights from 7 Sites. And we'll talk about private star parties. Thank you for listening. See the sky this week. I'll see you next week.